Good morning, everyone. Thank you for joining for the Security Working Group session today. My name is Jamie Gillespie, along with the others that are helping manage and maintain the Security Working Group. We have Yoshiaki-san, Shankar, and Rakesh. We have Yoshiaki-san here in the room. Shankar will be joining us for a presentation a bit later, and Rakesh was not able to join in person for APAN59. The Security Working Group session for today, we have two sessions for before and after the tea break. Not sure if we're going to be needing the second session. It does depend on how long some of the presentations go, as well as some discussions. We have three presentations that we'll be doing today. After the three presentations, we're going to be having an open discussion looking for ideas and support for ideas going into the future for how the Security Working Group can benefit the APAN membership. I won't spoil it too much, but if we do end up having the three presentations taking up all of session one, I do request that people interested in the Security Working Group come back after the tea break, and we will have the open discussion during the second session. If the presentations go a bit quickly, or if maybe one of our presenters doesn't turn up, we may have that discussion at the end of this session. So we'll see how it goes, but I do invite you to participate in the open discussions. We are not a dictatorship of the four of us that are leading the Security Working Group. We do want to make sure that the working group benefits back to the wider APAN community. So the presentations that we have, we're going to be starting off with John Lau, starting with preparing for post-quantum cryptography. We then have Shankar starting a sharing session for collaborating with international partners for real-time detection of malicious TLS traffic using machine learning classifiers. And we have Rupam, who is one of the APAN fellows, presenting on NetSec neural network for work that he's doing as part of his undergrad. So I'm going to hand it over to John to start things off with his first presentation for today.
Okay, good morning, everyone. Actually, this is more of a sharing session. I've been doing this quite a bit in Singapore. Did one of the sessions also in Thailand, and then another in, where was that, in Canberra. So anyway, this has been a topic of interest in Singapore, partly in terms of awareness, right? So I think some of these topics may be, or some of these things I'm sharing today may be, no, you all may know about it, but let me just go through, and then I'll share a bit on how in Singapore we are moving towards educating and pushing ahead with quantum, and especially in the area of security mitigation, right? So our banks, etc., has been doing this quite a bit, and even in the area of QKD, quantum key distribution, the Singapore government has also set up a test bed for the banks and for whoever is interested to try. Just a quick background about me. So I'm John. I hold a few portfolios, as you can see in the last line, where I'm part of A-Star, which is the National R&D Labs. And in that portfolio, I'm looking after the whole cybersecurity for our 7,500 staff, researchers. And it also houses the Quantum Strategy Office, in which then I help to look after some of the concerns in terms of cybersecurity. Yes, they have other objectives like getting researchers in quantum to Singapore and looking into quantum engineering, etc. I'm also helping Francis in Singapore, and also have been recently appointed as part of the Quantum Security Working Group co-chair. And this looks after then all the industry and commercial parties in Singapore, and again, it's to get them ready for the quantum wave, or rather quantum cybersecurity wave. In my previous portfolios, I've been involved in APAN quite a bit. During my national grid days, that's where I started being involved with APAN in the e-science working group even, and then I've been in other portfolios along the way. Okay, so I'll be sharing a few slides, and you will see a lot of this beautiful chandeliers, okay, of what I prefer to call them, of quantum computers. They are from the respective organizations that I will list down and give them the credit for them. This one on the right is the IBM Quantum computer, right? But again, the motivations for quantum computing, and this all goes back to where researchers have realized that quantum mechanics and how it works maps very closely to how a lot of the complex problems that the researchers are facing can be solved in a faster time, right? So, and also the other areas that because classical computers are reaching their limits in terms of processing power. Won't go too much into this, but we know about the superposition whereby instead of ones and zeros, quantum uses a spectrum, what they call qubits, right? So it can be represented any one time in various forms within, and that gives it ability to represent different states, and that's why in a way it processes a lot of data faster. Entanglement, and this is used a lot in the quantum key distribution, which is when one particle changes, somehow or other it affects or influences another particle at another space. So that also creates a lot of capabilities in the parallel computing. I won't go too much into this, but just understand the mechanics behind. I'm not a quantum physicist, so I will go into this, right? Maybe someone out there is. But I just wanted to share, this is where, really you've heard about how quantum could speed up a lot of, the different algorithms that we have, different ways of doing things. So in terms of modeling and simulations, we have seen algorithms being able to do this faster. In the area of optimization, these have also proven. So in the area of the algorithms and they have shown how quantum computing could speed it up, right? So I'll just share, all the different areas, but I'm highlighting the different blue words here because they all have similar attributes, which is a lot about quantum speeding up of simulations, speeding up of processes, etc. But I'd just like to highlight the last one, which is more relevant to our working group, which is in this whole speeding up of things, it also speeds up the ability to solve, our cryptography issues, right? So that's where the threat comes in. If you know about this is Shor's algorithm, right? So he is the one who came up with a quantum algorithm for integer factorization. And what this simply means is that instead of exponentials, instead of being an exponential problem, it has now become a polynomial problem, right? Which means that instead of a longer time to solve it, prime numbers are now able to be broken in a shorter time. Example will be, if you look at this, and I mean, this is just a theoretical kind of computation, but if you talk about a 300-digit number, right? In a classical computer, you probably take about 150,000 years, but in theory, quantum computers will be able to break them in a much shorter time, in this case, about 1 second. Okay, so this is what we are probably facing. How does this affect? So we know about RSA. RSA has been the basis of a lot of different cryptography that we have, including SSL, etc., TLS. So if this is compromised, or rather if this can be speed up in terms of breaking it in a shorter time, what it does mean is that a lot of our current encryption algorithms or preventions would be compromised in that sense. So RSA underpins a lot of the PKIs that we do, right? And what is this used in? We all know, right? In emails, in our SSLs, in our digital signatures. Okay, so now it's where we are then looking forward and say, okay, so what should we do? Okay, so one of the things is that, is there an algorithm there that is quantum safe, right? So that was the first question that was being asked, and whether we can replace RSA with some of these algorithms. So NIST did a search. I think about 80 different algorithms were submitted. Out of them, 10 were shortlisted, or 20 were shortlisted, and then in around August last year, they standardized into 4. Actually, 3 were published, 4 were shortlisted. Right, so that's how it has evolved, and therefore this 3 that's being standardized is now being pushed forth as the algorithms for implementation, right? So the crystals kyber, the crystals dilithium, and as well as the sphinx. So these are the three. It caters different areas, not just the comms, but in digital signatures, right? So this is the way forward. We'll go through this, and so so the next thing that people are asking is, okay, so we are changing algorithms, we are rushing for this so-called Q day. When will it be? Right. So some are saying 2035. Some say it's a decade. Bill Gates came forth, I think, of yesterday or the day before. It says it'll be 3 to 5 years. Right. So exactly when, right? The Global Risk Institute did publish this, and they are looking at about 20 years, or rather 5 years for it to start getting some traction. 10 years, 20 years, whereby that's why I'm looking. So 2035 seems to be around the time frame. The thing here is that this is the public information, right? When it comes to military, when it comes to, state-sponsored activities, this may be much earlier than we think. If you talk to the gurus in this space, if you talk to IBM, they'll give you a hint of when such states are more available. But just to go back, so Google did claim quantum supremacy. That was in 2019. A lot of controversy over whether is it Google or other companies, but this was published in Nature journal, so they have made that claim. This is the Sycamore 54-qubit processor Sycamore. Again, the qubits, if you read a bit more into qubits, other than physical qubits, now we are talking about logical qubits because of the errors that manifest in the physical qubits. So again, things are evolving, and we're getting a bit more accurate on the capabilities or the power of quantum computers. Yeah, so one of the things to note is this risk is really in the asymmetric space, right? If you're talking about symmetric space, they are not that. I mean, yeah, if you talk about pure encryption, no, they're not in that threat yet. Okay, so just to note, so we have always been talking about encrypting our data, etc. Those are not, but all the ones in the asymmetric space, whether it's digital signatures or in RSA, those are the ones that are there's risks. There's another talk going on now about harvest now, decrypt later, whereby they say that threat actors are collecting all the data and waiting for the availability of a quantum machine, and when that happens, everything would be broken by them. Again, the question is whether they can get the keys to it, right? And I was mentioning just now that actually in a symmetric space, it may come one day, but it's not in the near future. So then the question there is, when you're transferring data and you're transferring maybe the asymmetric key, whether they can have a way to collect the asymmetric key first, and then the actual symmetric data, and then in the combination they'll be able to break it. Yeah, just read through some of these slogans or hype, right? And understand where the threat really is. Okay, I'll just touch a little on QKD. This is quite talked about, especially from our network point of view. We did do, together at the National Supercomputing Center, Singaran did help to test bait one of this, transferring data from one point to the other. So what QKD promises is that using, again, quantum properties to be able to transfer the keys, right, from one end of the fiber to the other. And then after transferring the keys, then you can use the keys to decrypt the data that is protected using the same key in a symmetric way. Right, so there are two channels here. The one above, which is more on the quantum channel. And then with the keys on both sides, you can use any normal network capabilities to transfer the data with the keys. So that's what QKD is about. The only thing about QKD today is that it still relies on a whole physical fiber that is quite costly. So until the day that it can probably, multiplex, or there's one technology published called QBird. maybe that would help to be able to do multiple QKDs on one single fiber. So let's wait and see how that takes on. But yeah, this has been mentioned to be one of the secure ways. So when we talk about PQC, right, the post-quantum cryptography and the 3 algorithms out there, there's no certainty that they will not be broken by a new algorithm and using quantum. So then that develops in a case whereby it may not be as secure for long term. QKD, because inherent is using quantum properties, this is definitely a more secure way, just that it's more costly. So there's a huge group of commercial companies supporting this in terms of QKD technologies. But I just wanted to point out that even in the past few days, I just pulled out 3 articles, and this is really things that are moving even in the past week, past the few days, right? So with ANU, Australian National University, they are also moving ahead to look at how quantum can advance. Even in China, they have published about a new 102 qubits machine. In Japan, there's collaborations to push ahead the quantum industry. And I was sharing just now that Bill Gates thinks they will come in 3 to 5 years. So let's see how the space develops over time. But in Singapore, what happens is that a lot of effort by the government to bring the banks on board. They have actually sent out an advisory back in February last year, asking every bank to start getting ready. And what they have asked is, firstly, to be crypto agile. Right? So this word, just to share, like I shared just now, when we talk about PQC, post-quantum cryptography, the algorithms, whether it can be broken in a short while, shorter time than we expect, then the ability to change algorithms becomes the next thing, right? So now we are not just talking about hardware asset tracking, software asset tracking, but now we're talking about crypto algorithms tracking, right? So this is a whole new space that so security professionals are going into. But one of the 3 of the areas that they did ask for from the banks is to be aware, right? Be aware not just at the staff level, but even at the management level, right? The CEOs, the CTOs and COOs, are they aware of this, and how much attention are they giving to this? Of course, maintaining inventory, as I mentioned, and developing strategies around addressing all the cybersecurities. Okay, so this is what the banks have asked, or rather the Monetary Authority of Singapore has asked of the banks to do. In Singapore, just to share a bit, we have quite a bit of emphasis in this. We have added 300 million to existing 400 million to up our quantum capabilities in terms of the engineering and also in terms of the local expertise in terms of PhD and master's level. So these are the areas. In Singapore, the Center for Quantum Technologies, which has been existing for quite some time, is the one that is taking the lead in terms of the technologies. The Quantum Strategy Office basically coordinates all the activities there. Okay, I won't go into this, but we were mentioned by the National Cyber Director, Harry Cocker, right, who made this remark at the White House event. We have put in place, as I was sharing just now, that quantum safe network test bed, so that the banks, as well as whoever is interested to test, can do so. So this has been set up for the various users, and they can now access a test bed to try out QKD to their enterprises, the banks. Singapore has also offered ourselves for the R&E, but this is, again, based on take-up. Okay, so with that, I'll end my short sharing. Basically, we need to be aware, and so that's the task of the working group that I'm in back in Singapore, to share as much as I can. I've already shared it openly to my IT department in A-Star, and we'll try to do more of this. Right, so address the strategies, build capabilities. In Singapore, the Cybersecurity Agency of Singapore, they are also test bidding, getting everyone ready. So they're coming up with quantum readiness guidelines. This should be announced sometime this year. And as a start, they are testing out with some of the industry commercial companies. Right? Because some of these may be a bit onerous if you ask them to go through and get all the crypto assets. It is going to be quite a huge effort. But maybe it's necessary in the light of quantum threats. Okay, so I'll end with this, and thanks for your time.
Thank you very much, John. Does anybody have any questions that they'd like to put to John? Wonderful. One question for me, though. For the average research and education network, not just the NRENs, but just individual RENs that are there, what would be some of the intermediary steps that you're seeing before moving to quantum key distribution, the full solution beyond there? Would it be adopting some of the NIST cryptography algorithms that they've been proposing? Or?
Yeah, so I guess, I mean, in all our deployments, right, we are relying on the, all the companies who have, who are the makers of all our network, right, Fortinet, et cetera, right? Yeah. So we are waiting for them to come up with their solutions, and then we can do a replacement. But I think one of the things that has been the challenge is that they probably need to have a coexistence strategy, right, between the new algorithms and the old, and then how to transit. And that goes back to our browsers even, because a lot of it is still dependent on our TLS. So again, how are we going to transit? So the standards people have to come in, not hearing as much, but yes, I know they're starting to do it. And QKD is the other side of it, which is really using the channels itself. So I think that the two will go together. PQC, at one of the conferences, there was this guy who says, no, QKD won't work because it's one-to-one, no? PQC is one-to-many, right? So I do think there'll be the use of it will be depending on the need. I do see maybe the military and the banks and maybe the healthcare relying a lot on QKD because there are critical infrastructures as well as security. Maybe the layman will rely a lot more on QKD, and that's why we'll wait for the vendors to come forth with their solutions. If you talk to some of them, it's getting more promising. Some of their edge devices are able to detect whether in the back end it's using an old non-post-quantum algorithm. So that will help us be able to check internally whether we are relying on the old technology or RSA rather than PQC. Yeah, so
excellent. Cool. Thank you very much for your presentation, John.
Okay, so good morning, everyone. Allow me to introduce myself. My name is Shankar. I'm from University of Science Malaysia. I'm also the co-chair of this security working group. So this particular session is not so much about security, hardcore security, but it's more of a sharing session of a project that we recently, well, we're still undergoing right now. It's a security project, but the interesting thing is that we are collaborating across different international partners. So we would just like to share what are the things that we encountered. We still haven't resolved everything. It's still an ongoing project, but we'd like to share this so that if anyone that is actually embarking on a project that is of a multinational perspective, especially from an academia perspective, this may be useful. So the project title is actually Real-Time Malicious TLS Traffic Detection Using Machine Learning Classifiers. So the main goal, the purpose that we wanted to go for TLS traffic detection is that we have seen the transition of malware that are actually going into TLS because it's going to be difficult for us to actually do deep packet inspection to identify their communication and so on. So that was the real motivation. And here are our partners. So we have 5 partners, 3 from Indonesia. So the principal investigators from Hasanuddin University, Unhas. Then myself from USM. Then we have Universitas Syah Kuala from Aceh. We have Brawijaya from Malang, Indonesia. We have Buet, which is Bangladesh. And of course, we have KO. So this project is actually a CBR project under SOI Asia. CBR stands for Community-Based Research. So pretty much they funded the project. And the main goal of this project is to actually establish a research platform that would allow us to carry out far more newer research as long as the platform is still intact. So we use the TLS detection as one of our use case, but moving forward, we could actually apply it to anything else that the other partners are actually involved. So as I mentioned, the focus of the project was on detecting malicious TLS traffic. Then our emphasis was on getting real-time traffic analysis done on IDS. And what's interesting is that we wanted to actually come up with an AI model for IDS that works across different domains and networks. Just as a background, from an academia perspective, a lot of the data sets that we have right now is actually created in maybe a simulated environment, which is very specific to the environment. And whenever we apply whatever we have learned from that particular data set into a real network, oftentimes it doesn't work because of the nature of the traffic itself. And now when we're collaborating across different partners, we already see this from the beginning. The amount of traffic, the type of traffic that we see across different partners are already different. But how can we actually leverage that to have an aggregated model that will still work? That is the end goal of this particular project that we wanted to do. So how we deployed, so we have 5 partners. So 5 partners excluding KO. We have gotten our infrastructure, we have gotten our hardware. We deployed in our respective universities, our network. So pretty much all of the intention is all of our partners are supposed to actually monitor the traffic on their core network, as well as to actually have a detection mechanism that's going to train locally and then send to the so-called KO aggregator, where we will have a global model afterwards, which could then be actually visualized using a web dashboard. To be more specific, here, well, this is a very old slide where we don't have BUET in this particular group. So individually, each of us will actually generate a data set that we will be able to use to train. And then we will train locally and then send the train model to KO University, where we will actually cross-train across. And this cross-train, or we call it aggregated model, will be then sent back to the respective partners, where we can actually use it to infer malicious traffic or malicious detection that we see within our traffic moving forward. So that's the goal. And I think this is the pretty standard way, so we capture traffic. The top part is where we do the training part of it. We do data processing, feature extraction, model training. We validate the model, then we send it across to the KO. Then once we have everything, we will infer it with the same way as well. So this is pretty straightforward. This is not something new that I'm introducing here. Just to show the complexity of the problem that we faced, each of our university have different setup. Some of them have only one ISP, some of us have multiple ISPs, meaning we have multiple gateways. There are in some cases, we have load balancing and so on. Even in the case of USM, at the point of us starting the project, we only had 2 different ISP that we were working on. Right now, we have Arena Pack, so technically we have 3 gateways that is established for our USM network itself. But again, this was when we had only MyRAN and also our commercial traffic, so that's ISP1 and ISP2. So in our case, we actually mirrored the traffic, or rather we tapped the traffic from our internet gateway switch into our device, which is what we call here the packet capture and processing server. And the intention is that we will actually train here and then send the model to KO moving forward. Now, all this is the theoretical on-proposal part of it, right? Moving forward, when we wanted to acquire hardware, we started seeing issues across partners. Not issues, but difference of opinions. Except USM, all the other partners decided to go with the machines of this spec. The main reason why we didn't go with this arrangement is that we already had another server. It's a powerful server of the previous project that is not being utilized right now. And we thought of, instead of getting another machine, why not we just upgrade the machine so that we have better specs and so on. But rightfully so, I think we should have paid more attention to it. So when we had to actually get the GPU, all of us had GPU. So in their case, it's pretty straightforward. But the GPU that we got, it's for the data center one. And when we budgeted the application, we didn't factor in the license of using the NVIDIA's data center GPU. So on the hindsight, we should have thought about this in the beginning. But it's OK. For the purpose of the project, we can still use the CUDA library. So that's not a big issue. So that's the first part, which is the spec. The next part is sourcing the components itself. The project was supposed to start much, much earlier. But that's the point where we had these chip shortage issues and so on. The Indonesian partners were not able to actually secure all the components at the same time. And we also had issues where certain partners cannot actually purchase themselves. So we had to actually consider having another partner to help to actually source the component to them and so on. So it's not really straightforward from the proposal versus the implementation. But we wanted to have the same setup so that whenever we have issues, we could actually help out easily. The other issue we had is that we had to actually implement on a 10 gig link. All of us were using a 10 gig link, and the SFPs that, SFPs that we had, SFP modules that we actually bought, for one partner, it was cheap, the component, but it wasn't able to actually withstand. So then we realized that there is this, how do I say, a knockoff model, which is not the original model at all. So whenever going for this kind of modules, please take into consideration the proper pricing and make sure you invest on the original one if you do not want to go into hiccups later on. So this is for the sourcing components part of it. Next, for the traffic capture, we deployed a fiber tab, something on the top right, in each of our network. And the fiber tab basically tabs, and then you have two interfaces that you have to actually monitor. One is the incoming and outgoing traffic. The first issue we had is obtaining permissions. At the point of writing proposals, everything seems straightforward. Yeah, we will ask this permission and everything will be fine. It wasn't the case, and wasn't the case not because the universities or the network owners were not agreeing, it's just that the policy changed across time. In my case, in our university, we started having a new committee. It's a cybersecurity committee that decided that they will review anything that that is going to be implemented or carried out in terms of research or even production in the university. And unfortunately, in our case, the moment that we actually start saying traffic capture, the word, that triggers a lot of panic. Right? And people started asking questions. Oh, you can see everything that's happening. You can start monitoring the network traffic, my emails, and so on. Of course, the first thing that I got was rejection. I had to actually go through explaining to them, giving them details, and saying, no, we only see, we convinced them by saying that we are only getting the encrypted traffic, which means I will not be able to see what's inside. So there is a part of education that we had to do to convince the stakeholders that we're doing this and nothing that you're afraid of is going to be jeopardized. So that's a lot of effort that we are having. And another partner of us, interestingly, there's a new law in their country that made them having to go up to the ministry to get an approval because a network being tapped. And they are also riding on their national RAN traffic, so multiple parties are actually affected. So the process of getting permission isn't as simple as it is, versus you have your own network, you have your own testbed, you don't have to go through all this. But the moment you want to go across different partners, especially multinational partners, a lot of things will come into the picture. Next, we need to actually synchronize the hardware timestamps because we have two different interfaces that we have to actually tap from. This is pretty easy, actually. So we have technical solutions. We have, for example, we can actually use PF-Ring. PF-Ring is actually doing that for us. So that wasn't a big issue. But yeah, one of our partners actually assisted us in this. Another thing I would like to highlight is that having 5 partners, well, 6 partners in this case, was very unique for us, whereby we never needed to actually say, you will have to be in charge of this and so on. The experience that we had is very interestingly positive, where everyone chipped in their expertise, their knowledge, to make sure that everyone is up to the speed in terms of executing the project. And I truly appreciate that. Anyway, so for the capture method, we initially wanted to go using Surikata. Surikata is an intrusion detection system. The purpose that we want to use the IDS itself to actually capture the traffic is to actually assist in labeling. We are working on real-world traffic. We have no clue what's going to happen, especially if you're just looking at TLS traffic. So we thought using Surikata would actually resolve our issue, but of course it's not as simple as it is. We had a lot of packet drops, and hence we are now considering PF ring or XDP with a combination of Surikata to overcome that. We have tested both. We do not have packet loss when we are implementing it with some parameters that we had to change, but this is still being considered. The next thing is that we wanted to use TLS traffic. The question was whether TLS traffic that is destined for port 443, whether source or destination, is good enough. We found out, nope, it's not good enough. You only get a fraction of TLS traffic. We started seeing a lot of traffic that is not just TCP, we also start seeing them on UDP. So we have different protocols that are riding on TLS, and you cannot actually assume that the malware will only use HTTPS, right? So malware will be using whatever they want, so we have to actually extract all of it and then consider. Then the next question is, right now, should we just go with flows, or do we need the raw PCAP? I'm still talking about the training process, right? So we did a small experiment in my university, in my building, where we host 3 different faculties. We have our computer science, my research center, the School of Mathematical Science. And our traffic for just 24 hours compressed is just 1.4 terabyte compressed. And that is all traffic. And if you just have to filter out TLS-based traffic based on the filter mechanism, we could actually reduce the raw PCAP, which is compressed, for about 75%. But the thing is, 1.4 tera for my network, which is supposed to be small, is still high. And compared to the other partners, and especially when we're actually tapping on the core backbone, it's going to be significantly high. Even though we are just talking about the training phase, storage is a concern that we have to actually take into consideration. So the goal is actually to minimize the capture traffic, because we only need it for training. And remember what I mentioned earlier, the objective is to do real-time analysis and real-time inference later on. So let's assume that the storage part is actually resolved. We were thinking about how to train the individual model, how to identify attack traffic, meaning we need to have label traffic. That's where the idea of Surikata came into the picture. But the question is, how much of the TLS traffic that we will see? It is left to be answered. So we decided that we need our own labeling of real attacks. Hence, we decided to actually go with the honeypot deployment. So all of us actually deployed a T-pot honeypot, which is from Deutsche Telekom. So T-pot, for those who are not aware, it's a combination of multiple honeypots. So you have Cowrie, you have Dionea, and multiple other types of honeypots which is compiled into one. So it's easy. It's also available as Docker. And how do we intend to actually do the ground truth data collection is that each of our partner will have a honeypot with a known IP, of course. And we plan to actually, when I say we plan, we haven't executed this part yet. We have prepared ourselves. I think in the next weeks, we will actually do this. We will do coordinated attack. Now, attack here doesn't mean that we are going to do a DDoS attack. We are going to carry out a series of TLS-based attacks or known TLS tools to actually, TLS attack tools to launch on these honeypots, but in a coordinated fashion. When I say coordinated, it is more of, do I have it here? Yeah, okay. So when I say coordinated here, it is more of, we have some scripts that is going to leverage these known TLS tools. I think you can capture them from, you can gather them from Kali, but we also went through all open source resources to see which are the suitable ones. Because the idea is we want to see all kinds of TLS traffic. So we will not know what kind of TLS traffic is going to come if we just rely on external attackers. So we wanted to inject our attacks. And we have a script that will automate the process with some randomness, but using a compilation of TLS attack tools. So this script will ensure it takes note of who's the source attacker. So each of the other partner will take the role of an attacker, and we will have a log that actually documents from which IP this attack was carried out, to which IP, at what time, and what are the sequence of events, so that we have this ground truth that we can actually collate later. And later, we will actually aggregate all the different data sets, the capture traffic from the different partners, along with the ground truth of which are the attacks that we had. We will anonymize the data set, remove the payload, and maybe even pure flow data, and then make it available for the research community to use it. But we will retain the raw PCAP for future investigation. Because honestly, we don't know what else we are going to use it for. So we will just retain it among the partners. So the collection of the packet itself, so we decide to actually monitor on the segment towards the honeypot or even on the honeypot itself. So the network traffic will come in. We will extract the flows and look through a sliding window of X minutes. X is going to be parameterized. And we will actually go through the Surikata engine. So we'll have some sort of labeling that's already being done. And then we'll also collect the activity logs from the honeypot itself. So the idea is that we can actually compare the activity logs with the Surikata logs, or Surikata alerts, and see whether there is something that the honeypot saw, but Surikata missed. Meaning we could potentially see false positive. That's the intention of having logs at both sides. And TPOD is running, we have decided to run on Docker. It requires 8 GB memory and 100 GB storage. So we decided to actually make sure everyone uses the Docker version of it. So at the top, we have the TPOD logs, we have the Surikata logs, and we also have the log of the attackers, which we generate ourselves, among other attacks, right? So once we have all this data, for every X minute, we'll actually cross-check with our Surikata alert for every honeypot logs that we have seen. If it is there, then we know, yeah, okay, this is a verified attack. If it is not in the Surikata alert, we will then check whether it's existing in our attack log. If our attack log indicates there was an attack, I mean, there was an activity, and the honeypot saw that, but Surikata failed to actually label it, then we know it's a false positive, and then we will actually label it in our data set. Otherwise, it's also known as a verified attack. So this is what we intend to do in terms of labeling and getting the ground truth data set up and running. Yeah, let me just finish it up, then we'll open for questions. So lessons learned, I think some of the things that I mentioned earlier, we need to plan and execute early. And when you work across different partners, I think it is wise to assume you will definitely have hurdles. And it's not going to be smooth, let's put it that way. So plan for contingencies, have some times. And I think the key thing in our partnership is that we had regular meetings and we were able to actually resolve it early. So that was really good. And as I mentioned earlier, so work together, contribute collectively. It's not like, hey, you are responsible for this, you have to do it. We didn't go with that approach. Thankfully, we were all coming in together. Everyone was chipping in whatever resources, whatever knowledge that they have. That really helped to boost the morale of the team as well as the progress of the project. And the collaboration across the institution was really essential and will be very, very useful for cross-network analysis. And I think the platform that we have right now is a stepping stone for many other research ideas and also directions that we could actually carry out. As future work, so we are now in the process of finalizing our ground truth. After that, we will actually do the machine learning part of it, which I didn't share anything about the models and so on today. We will continue maintaining the project despite the project going to end. I mean, the official project duration is going to end because we see a lot of potential in this. And then one of the other things that we want to do next is to explore federated learning as a learning method to preserve privacy while aggregating the learned model and so on. I think that's something that other institutions may also be interested to be part of, especially when we can convince them that, hey, your data will never have to come to us. You can actually just share the learned model, and then we can actually work with it. So that's the sharing that I have for you guys today. And with that, I end my session, my talk, and I open for Q&A or comments. Thank you.
Thank you very much, Shankar. Does anybody in the room or on Zoom have any questions that you'd like to ask of Shankar? No? Excellent. Good information sharing. Thank you very much for that. And Rupam, are you ready to present? You're all good? You happy to use your laptop? Wonderful. Come on up.
Good morning, everyone. I am Rupam from India, and this is a project that I built for my college last semester, and I'm a student, I'm a fourth-year student in cybersecurity. So the project is about how we can like improve in the aspect of intrusion detection systems with the use of AI, because like as we know, IDS is mostly a rule-based software, like the software IDS part actually. So what I wanted to do is like explore a little bit about how we can use AI to maybe like make it a little bit faster, or maybe change some traditional things to like implement new things. So this is the motivation. So there are a lot of complexities in the current types of attacks in the cybersecurity space, and traditional methods really struggle to handle those. And we need maybe we need AI inside the project. So yeah, the introduction to cybersecurity, like what is cybersecurity? So a system that prevents from evolving threats and like safeguard against attackers. So what this project does, this is a project, it is a like feed-forward neural network, which is using AI-based model to classify the network patterns that are like packets coming into a system, and it will be check on real time and like classify if this is a threat or a benign attack, and based on like that it will generate alerts. So like there are three objectives, which is like obviously enhance network security, or this will not be of any use, and like automate network analysis and improve accessibility, because like IDS is a software that like non-technical people will not be able to use, but if it is like really easy to access, then a lot of people will be safer and will be able to use these softwares. So I have worked with two research questions. One is what can we do to figure out what's happening in the network, and like how to inform the end user to like about what's happening under the hood in the network. Yeah, there is like for the research design, we have I've used two things like of comparative study. I've used like different forms of machine learning models, and one is the practical approach to like deploy it in a environment to test if it's working or not. The data set what I've used is this is a really old data set. It's from 2017, created by the Canadian Institute of Cybersecurity. It is the CIC IDS 2017 database. It has over 2.8 million data points, and like have 15 plus types of network traffic inside it. Like the methodology is I have the like dataset preparation, because it has a lot of like bad data inside it, and like the processing. And I have like after a lot of back and forth, I selected the feed forward neural network because it was giving the best results. And for training, it is the like standard thing 80-20 training split, and like I have deployed it in a website. This is the architecture of the neural network. So I have a hidden layer and like two dropout layers, and at last the output here. So for the solution, there are like yeah, as I said, 3 hidden layers and ReLU activations, and the output is based on binary classification at first, and I am currently working on a like multi-classifier model, which is like more complex and have more types of anomalies inside it. So this is currently this is the binary performance metrics, almost 99.94% accuracy on test data. And so this is the test data that I've not used in the model, and not even in the like test split of the dataset. And there is also like this was for my like dissertation for my college. This is not like part of the project. And like we also have visualization of lost data and like things. So comparison. So this is not a new thing that I have implemented. A lot of people have implemented the ideas, but like using a neural network, this is like very few people have implemented, and like with like good results. This is also scalable architecture. So like people with a lot of data coming into the network can also use it. For conclusion, I have this has significantly like improved what traffic is blocked and what is not, and so this is also have a high accuracy and a real-time usability. And like limitation is like I rely heavily on the dataset quality because like I don't have my personal dataset, and there's also like really large scale deployment. It is kind of hard. Like it is scalable to a certain point, but after that it starts to like break down. So future scope is actually I currently have hosted on a website which you have to like manually do some certain things, but I want to like, do it real-time analysis which like implement it and forget about it, and it will do everything on its own. So scalability, it will be like deployed in the cloud deployment, and like more advanced models and like broader applications for like IoT security or fraud detections. And like hardware limitation, like whole data set is a singular model. Like I want to have a multiple distributed models that can like be doing the same thing at the same time. These are the references. Sorry for like it's a short presentation. And do you have any questions?
Thank you very much for the presentation, Rupam. Does anybody have any questions, either in the room or on Zoom, that they'd like to ask for Rupam? No? Excellent. Thank you very much for your presentation. Yep. Oh, not seeing anything on Zoom, so it's all good. Thank you. Okay, so presentations went well and on time, so we do have time for general discussion now, which is going to be good. I've got a captive audience, so we'll just lock the doors and prevent everyone from leaving. I'm not going to stand behind the podium. I need to come out front a bit. One of the questions that we've been asking as the co-chairs on the security working group is, what does the APAN community want from the security working group? The security working group was started, I think, what was it, around 2003, long before my involvement in APAN, long before I think any of our involvements in APAN, and it has gone through different changes, different chairs, different focuses, and different use cases. In the past few years, we've been using it as a forum for presentations during the APAN meetings. But as a lot of the working groups have experienced, there wasn't much activity going on between the APAN meetings. Now, it is only every 6 months, so there, we do have meetings twice a year. But one of the questions is, we can go back to the original information on the APAN website about the security working group, and the fact that the security working group started off with objectives of providing advice to NRENs, providing advice to APAN as an organization and to its members, as well as providing a forum for sharing of information in that. So while we can, of course, continue with soliciting research presentations, information sharing, technical sessions like this that we've been doing this morning, we want to know from you, the people that are interested in the security working group. Hopefully that's the reason that you're in the room, is because you have an interest in security, and finding out, do you have ideas, do you have wants and needs that you would like from the security working group, and how can we, as a working group and the co-chairs, get the information, get the knowledge, and get the sharing that you might be wanting. So I'm trying not to put forward my ideas and some that we discussed as the chairs, but in the room or anybody who's on Zoom at the moment, does anybody have any thoughts or ideas? It doesn't have to be a great thought out idea, but just even a small little piece of an idea that we can then expand out on. Does anybody have anything that they'd like to share beyond just presentations? Yes, Rupam, I'll pass the mic to you.
Yeah, like one, like we can have an open source project, like that, fellows in APAN or like people who are attending APAN can contribute in, which can be like led from like few APAN meetings. Like this can like improve a lot of interaction from like real technical folks, which are like programmers and stuff, so they can make projects and like have a bigger impact for that. Yeah. Thank you.
So is your thought on the development of projects or the sharing of data and resources? Because we were seeing from a previous presentation about the collection of large amounts of data and that can be provided, but then also people like yourself that are actually working on projects.
Yeah, I would root for the development of projects, because like there are a lot of data that we can like collect, then like have a projects built on that. So like also like developers can also like have a like contribution inside it. Thank you.
Thank you for that suggestion. Does anyone else have any ideas that they'd like to put forward? Again, it doesn't have to be a well thought out or a polished idea, but yes.
I think network security is a very wide topic. So for today, most of the topic are focused on the application layer. So actually, we have many network security problems, such as from the low layer, such as some tapping, flow tapping, and BGP hijacking, DNS hijacking, and DDoS attack, vulnerability, application layer, some how to detect all these things. So I think it's a very wide topic. So maybe this is the first time I take part in this workshop. I think maybe we should have been more focused, so the audience we can know what this session, this workshop is for. We can split into a series of workshops. Yeah, we can have many sessions each layer. I think we can have deeper discussion on this. Thank you.
So looking at the layers from network, not just at application, but down to network layers. Yes, many layers. Excellent. Does anyone else have any other thoughts or ideas? Yes, John.
Yeah, so yeah, I was listening to Shankar's sharing, and I thought, I think two security group, 2 APANs ago, I think there was also sharing by I think NICT or NI about securing the different at the edge, right, of all our different organizations. In Singapore, that's what we are doing. So for Singaran, we are also monitoring all the traffic going up internationally, and so that we can detect if there's a coordinated attack to all institutions. Yes, there's a lot of sharing agreements that we need to put in place, because yes, we are monitoring their traffic, and also we have also gotten all the institutions together to form a security special interest group. So that, I thought there's a bit of effort on the area. Then I think there was a question then was about, do we help to block the traffic at the edge, or let it through and then the organizations have to do it themselves? So I thought but that's at the strategy level, right? Really higher. But I thought that would be areas that we could share how to do it. We are talking a bit to David over at ARNet to see how we can get some of the help. So I think that's again another opportunity maybe for ARNet to share what they are able to provide as a service to the other NRENs around. So I thought that's at a higher level. Yeah, thanks.
Well, thank you. Yeah, you've basically gotten to roughly the idea that I was having for something that we can do. So, what I was thinking of is basically taking some of the structure of how the network engineering working group runs some of their sessions, where they actually have presentations from each of the NRENs on their transit activity, their POP activity, what they're doing in that space. And like they run 4 sessions, they run an entire day of network engineering, and that's not even really talking about security in any way. That's their pure networking roles. So, one of the thoughts I was having is providing the dedicated security space in the working group to invite each of the NRENs to present on what they are doing. And, you know, starting off with wide open, because every NREN has different services and operations and different models that they operate in. So it could be, you know, what are you doing to do security within the NREN as the organization? What security services are you providing out to your members? You know, anything in that space to allow for the different models to be. And by having that forum and getting NREN representatives and presenters here, hopefully here and not just online, but getting everyone to present, there can be that shared learnings. Especially if someone says, oh yeah, we've been working on this, and other people are like, oh, we've been thinking about that. Question, you know, how are you going? What was working well? What were your pitfalls and everything? And really getting to that, not just one-to-many sharing, but then that many-to-many interconnection.
I mean, Shanka was sharing about the honeypots, right? I mean, we highlight for honeypots. I mean, you at a high level, yeah, we can talk about honeypots, but actually in implementation, there also is challenges, right? So we happen to meet up with shadow server organization. So that's also another opportunity that we can contribute maybe back to the bigger entity. But yeah, these are sharing sessions that we could have.
Yeah, no, wonderful, thank you. So with that type of an idea, what do others think coming from different NRENs and different organizations and RENs? Do you think having presentations from each NREN on the activities that they're doing and have that question and answer time between them, do you think that that would be beneficial to use this working group as that forum for that? Do you think that that would be bad? It's hard when everyone's quiet. I don't know if that's silent agreement or silent disagreement. So. With that type of an idea to start things on, that is not the only thing that we can do, of course. We're looking for many ideas. Does anyone else have other ideas on what we can do as the security working group, as a group and as a forum for security amongst NRENs and therefore onto RENs as well?
Thank you. David Wild from ARNet. In fact, the suggestion I was going to make was not so much an ARNet idea, but because I'm part of a kind of collaboration called the GNAG, which tries to be a global sort of NREN collaboration. Yep. It has a number of working groups, and it has a Securing the GREN working group. And sitting under that is actually largely an activity run by Ana Alves, who's with Géant, and she runs security boot camps, which are intended to take less well-resourced NRENs and I guess teach them the basics of how to secure your own organization. I'd love to try to link up her. She was actually, I believe, meant to be here this week, but isn't. But as you know, I think she'd be really keen to talk to Asia Pac NRENs about organising boot camps like that. I don't know if that would be of interest to those in the room, but it's basically a simple recipe of here are the 5 things. If you do this, then you'll be more secure. Yep. Yeah. So that would be the first thing, and we've already got a bit of a model for that, the routing working group, which Brenna Mead and Warwick Mitchell from ARNet, it's kind of a joint GNAG APAN working group. So there's kind of a recipe already for working closely together in that way. Yeah.
No, excellent. Yeah, it'd be great if they weren't able to attend this meeting from Géant, if they can come to Hong Kong in August, is it? Which is coming up very soon. But yeah, it'd be really good because that might be a good presentation to present on and then see, you know, if that's something that we can pick up and run with in the APAN region. Yeah, thank you. I come from a training background, technical training background, so I'm always big on that if it's something that would be, you know, accepted by the RENs in the region. One other idea that I was having just to maybe kickstart some other thoughts and discussions is in the same way of sort of a security boot camp, but not just a collecting of 5 things to do, but maybe a collection of best practices or looking to other organizations that have valuable information that maybe not every REN or NREN is using, accessing, or knowing about. One thought is around Shadow Server. Shadow Server is a wonderful organization with a wealth of information if you know about it, if you subscribe to it and access it. And it's free. And some people may even think that there is a monetary barrier when in reality that service is free, and maybe there can be some information on how to use it and best ways that other NRENs and RENs have been using it. So one idea was collecting these sort of best practices or, you know, good practices that we can collate into a central resource to possibly keep up to date and have that brought in from different NRENs, network operators and engineers and security experts, and then share that back out to the APAN community. So that, you know, we can basically have that documented learnings of good resources of information and good recommendations for secure practices on our networks. Anything, again, taking the layers approach, all the way down from a network routing layer, RPKI, of course, because I come from APNIC, and then moving up layers. You know, if you run mail servers, these are the security best practices from there. Again, not so much us creating them, but finding where they are, because they are out there. Routing best practices exist. Mail server best practices exist. TLS and in cryptography best practices exist and are evolving over time. So by bringing that together, hopefully it can raise the visibility and reduce the workload on security, network, and system engineers in applying those practices. So that's another thought that I was having. That, of course, doesn't have to be at the meetings. That can be done in between meetings and maybe presenting on it during meetings. But it's something that the working group, that as co-chairs, we can sort of wrangle and bring that information together. Does that resonate? Any discussions on that? Yep.
Maybe one point was about edu-roam. I think at the emerging NRENs, there was a discussion on, you know, how do you, where do you put the edu-roam, right, in terms of the network segment? So just to share for A-Star, right, we had been receiving, I mean, we keep it within, right, vendors, software vendors who have been coming to us and say, hey, we have seen from your IP address that there's unauthorized software belonging to the vendor that's coming from our organization, right? So they're detecting and saying that it's coming from A-Star because of our A-Star IP. So then the question next is that if we use edu-roam and that then uses our A-Star IP, then what is the, I don't know, acceptable use policy, or how does that translate? Right. It may not, I mean, it still could be a network segment outside, meaning it's still only internet accessible. But because of the use of our A-Star IP, our organization's IP, what's the implication? And how do we want to approach this, and what's the, you know, the considerations behind it, right? So I think this kind of questions may be useful because edu-roam is such a fantastic piece of enabler, right, in terms of using internet via credentials. Yeah. So maybe these are kind of questions we could also talk about.
Yeah, no, very good. Thank you.
Good morning, everyone. Eric Yan from Taiwan. I'm new to this working group, but I'm totally agree with what Jamie mentioned about the sharing of the best practices. Because the technology and also the attacker evolved so fast. So the sharing of case study from each APAN members might be very, very, very variable. And then based on those lessons learned from each partners, maybe we can formulate some kind of best practices for daily operations. The other thing is that maybe some partner already are running their security operation center. So any recommendations for establishing such center or any tools supporting that such experiences sharing might be useful for the community.
Excellent.
Yeah, thank you.
Yes, thank you for that. You know, and talking of security operations centers, yes, you know, some NRENs are providing that as a service to their member education networks. And beyond just a security operations center, something that's from my personal background is an incident response team as well. As a separate to the operations center for, you know, the monitoring and that, but the security response and investigation side of things, and how can that work? I do know that some NRENs provide that as a service in their community. Some economies provide a CERT team for the entire education network within their community. In Taiwan, of course, being a good example for that, having multiple CERT teams focusing on education, government, and general population. So yeah, so that could be some other sharing of information and sessions as well. Does anyone else have any other ideas or comments on the ideas that have been presented for things that would be useful for you to provide support behind, or maybe directing that, you know, some things may not be as relevant for you, but others would be? Any other feedback or sharing that anyone would like to give? And this applies for anybody on Zoom. I am watching the chat, so if any of our participants on Zoom would like to share any information, please feel free to join in as well. Yes. Go for it. You are allowed to have the mic twice, yes.
Thanks. On the topic of manners and RPKI, I would love the whole global RNA network to have that just rolled out 100%. Is that a desirable or achievable target for us?
As somebody coming from a routing background, yes, I would like to hope so. And you know, that's something that we could maybe even do as the co-chairs, is getting the information, because there is manners testing and assessments, and we can go through and maybe get some of that information. Or maybe even get one of our illustrious, you know, students that is coming through, whether they be fellows or otherwise, to maybe do that as a bit of a project of collecting the manners capability scoring for different economies, different NRENs, different, you know, individual education networks, and presenting on like a heat map of the Asia Pacific region. You know, where is manners fully deployed, partially deployed, and you know, still working on it.
No, I think Steve Follis, who is now a manners chair and part of the kind of routing working group, I think he'd be super supportive of like providing the recipes that he's used in North America to try to get it rolled out. So yeah, that'd be a great thing to, partly just to get a snapshot, but also really try to help and support and drive take up. And I must say, in Australia at ARNet, we've got ourselves covered, but our customer or member institutions are a long way behind. So yeah, I recognise it's hard to do. But yeah, a lot of value I think would come from that.
And that's that crossover between routing, networking, and security. But you know, I think we can really draw that attention to it as the security side of things. For anybody who doesn't know, manners is MANRS. It's the mutually agreed norms for routing security. So it's all based on routing security, BGP, such as RPKI, filtering routes, and other things like that. But there's five different aspects to it that need to be implemented to be fully manners compliant. But yeah, it's a wonderful, wonderful project. Does anybody else have any other suggestions, comments, or anything they'd like to add in for this part of the discussion? No, all good? Oh, yes. Oh, yeah.
Just want to touch on the part that we said we wanted to share our experience and all. I think that's something we hardly get. We always see the good things. We always see the best practices. This is how you're supposed to do. But being able to share the the hiccups that they face along the way, I think that's really useful because the other members, I mean, during the APAN meetings, for example, they will know, okay, so this person had this issue, I know who to talk to. And I think regardless of the topic, that is, I mean, so each NREN could share what they did and also what didn't work for them. So I think that will be very helpful for them to actually learn and grow together. Thank you.
Sounds good. I'm even, when you started talking about that, I was envisaging maybe having 2 sessions, one fully connected on Zoom and that, and one where we just go dark. We turn off all the tech, and we just have the in-the-room Chatham House rules, share the information of bad things that have happened or things that went not according to plan as learnings that we may not want broadcast or recorded. So, you know, and that could be something that we can put out there. So one of my thoughts is to have a survey that we can put out to the wider group. But from the discussions here, I don't know if we necessarily need the survey. I think it's maybe the targeted communication to each NREN, inviting them to present on any of these sorts of topics, and maybe giving a one little line in that email saying, you know, and if needed, we can pause Zoom broadcasting for a more honest and open sharing as maybe half of a session or something like that, and see how that goes. Because, you know, if we don't do it as a dark session during a session, it's just going to happen in the hallways anyways, because there's no Zoom and there's no broadcast and recordings at lunchtime and at the tea break. So if we can provide maybe a room and a structure to that type of sharing, that might be good as well. So yeah, so that's going to be my plan, is taking the suggestions from here, putting it into a nice formatted email that we can then send targeted to each one of the NRENs, specifically requesting them to present on some of these areas, possibly inviting those from Giant and others to present on those projects that they're doing in other regions as well, and see how that can be brought in here. If you can send me an email with contact details, that would be good. And yeah, I think this can be, you know, starting with APAN60 in Hong Kong in 6 months-ish. I think it could be a good way forward for the security working group. And, you know, we can try it over a few meetings, adjust things as we go, but I think this can be a good way forward to make it a very active working group community, and not just the chairs getting presentations from different organizations. Not that there's anything wrong with your presentations. Thank you very much for your presentations. But yeah, I you know, whenever I look into some of the other working groups and their reports and presentations, I'm trying to find the best parts of that and bring that into this working group as well. So thank you very much for your participation in that. Thank you as well to our 3 presenters for this session. We only had the 3 presenters and this discussion, so we don't have anything for the second session. We have the time reserved because there was spare slots available. So we won't be continuing the security working group today after the morning tea break. But if you do see any of us as co-chairs out in the tea break and afterwards, please do come up to us, share any thoughts that you may have that you may not want to have done over the microphones and on the session here today. But please, you know, if you are on the receiving end of my email as a request for APAN60, please do find somebody within your organization that can present the information at APAN60, even if it is over Zoom. You know, if you can't travel to Hong Kong, that's okay. Additionally, it may be one person creating the information but not able to attend APAN60. So it may have to be presented by someone else. Perfectly fine as well. And as long as we're getting that involvement from as many of the NRENs as possible, I think that we'll move to a successful increase in this working group's activities. So I'll close off the session for today. Thank you very much, everyone, for coming in. Thank you again to our 3 presenters. And I really look forward to seeing everybody coming in for APAN60. In fact, I may even request that we get a larger room just in case. Because if we do take on a style of network engineering, they were overflowing. They had people in the hallway, and they had to have a second room like this to do simultaneous broadcast. Of course, I'll also do my best to make sure that our sessions never clash with the network engineering, because it might have similar people presenting on a slightly different topic. So we'll see how that goes. But yes, please as well, please try and attend to APAN60 in Hong Kong. It is going to be typhoon season, but I've been assured that the hotel where they're holding it is typhoon proof. So yes, we should be able to have a successful APAN meeting for APAN60, which is a big number as well. So wonderful. Thank you again. Please enjoy the tea break and continue on to session 2s as you need to afterwards. Thank you, everyone.